the last part of your review is on stoichiometry. So this comes from the Greek word stoichion, meaning element. So basically, this is the measurement of the amount of your substances involved in a reaction. So all quantitative relationships involving your atomic masses or your molar masses, chemical formulas, and chemical equations. So in the stoichiometry, in this one, the balanced chemical equation is the most important thing. And because we get the stoichiometric factor from the balanced chemical equation. So what is the stoichiometric factor? Um, in simple terms, it's the ratio of the substances in a chemical reaction. So, for example, we have here how many moles of oxygen are produced from the decomposition of 1.76 moles of potassium chlorate. So, again, the balanced chemical equation is the most important thing. So, that's what you first do in stoichiometry. So, we have here potassium chlorate. This is potassium chlorate, and the products are potassium chloride and oxygen. So, we need to balance the chemical equation first. So we start with oxygen, and that gives us 3 over 2 here, right? But if we want to eliminate the fraction, so we have 2KClO3 forming 2KCl plus 3 oxygen. So we have the balanced chemical equation, so we can proceed with the problem. So it's asking for how many moles of oxygen do we get if we start with 1.76 moles of potassium chlorate. So we get the stoichiometric factor from the balanced chemical equation. So it's a factor that is a fraction, okay? So we start with the denominator. So we look at the coefficient of our given, which is potassium chlorate. So that's 2. So we have 2 moles of potassium chlorate. And then in the numerator, we write the coefficient of our target substance, which is O2 or oxygen. So we write 3. And the unit is moles. So 3 moles of oxygen. So you use your calculator to get the answer. So it's 2.64 moles of oxygen. So here we have another problem which is a bit leveled up. So what mass of carbon dioxide is formed in the reaction of 4.16 grams of triethylene glycol or C6H14O4 with an excess of oxygen? So what type of reaction do you think this is? So look at our reactant. So it has carbon, it has hydrogen, and it reacts with oxygen. So this is actually a combustion reaction. So you can easily write a combustion reaction. So it's C6H14O4, which reacts with oxygen. And always keep in mind the products of combustion are carbon dioxide and water. So we balance this. Again, you start with carbon. So that is 6 here. And then hydrogen, so 7 here. So we have 2 times 7, that's 14. And then last is oxygen. So on the right side, we have 7 plus 12, that's 19. Now here on the left side, we also have oxygen in ethylene glycol. So from 19, we subtract 4, that gives us 15. So I'm going to write here 15 over 2. So we want to eliminate the fraction. So I'm going to multiply the whole thing by 2. Okay, so if you check, we have the balanced chemical reaction. Now, Our unknown is the mass of carbon dioxide, and our given is 4.16 grams of triethylene glycol. So the stoichiometric factor can only be used if our unit is mole. But here in our given, our unit is gram. So we need to convert this gram into mole first. So again, what do we use to convert grams to moles? It's the molar mass, right? So if you check your periodic tables, the molar mass of triethylene glycol is 150.2. So I'm gonna write here 150.2 grams per mole of your triethylene glycol. So for this step, we converted the mass to the moles. So the next step will be the stoichiometric factor, right? Because we are already in the moles. So looking at the balanced chemical equation, so we start in the denominator, which should have the same as this one. So that's 2 moles of C6H14O4. And in the numerator is our target substance, which is carbon dioxide, right? So the coefficient of carbon dioxide is 12. So 12 moles of CO2. So now we have the moles of carbon dioxide. And how can we convert this to the grams or the mass of carbon dioxide? So we're going to use the molar mass. So the molar mass of carbon dioxide is 44.01 grams per mole of carbon dioxide. So notice, okay, the operations are reversed. If I'm converting from mass to moles, I divide the given by the molar mass. But if I'm given the moles and I want to convert this to gram, I multiply it. Okay? So using our calculators, the answer is 7.31 grams of carbon dioxide. So I hope you were able to follow that. Okay. So here is like a schematic to help you process the information. So we have here compound A to compound B. So this is regardless whether compound A is a reactant and compound B is a product. Both can be products, both can be reactants, okay? As long as they are part of the same chemical reaction. Okay, so I hope you will use this in our diagnostic test. I'm not going to give copies of this, okay? So please remember this. Okay, lastly, I'm going to introduce the concept of limiting reagents. Okay, so if you recall, we have what we call the stoichiometric factor. So if our reactants are in their stoichiometric amounts, it means that they are in their proportions indicated by the balanced equation. However, of course, in most chemical reactions, we start with non-stoichiometric amounts of our reactants, right? So definitely one of your reactants will get consumed first, and then you have some of the other reactant left, right? So the reactant that gets consumed first is what we call the limiting reagent. And the reactant that remains in the beaker, for example, is what we call the excess reagent. So as an example, If we want to make hot dog buns, so we know that one bun is to one hot dog, right? But let's say in my stock, I have five hot dogs and four buns. So actually, I can make four hot dog buns, but I'm left with one hot dog. So in this case, our limiting reactant or limiting reagent is the bun, right? Because the amount of our hot dog buns, the product, the hot dog buns, is dictated by the amount of the limiting reagent. And the excess reagent will be the hot dog. Okay, so I hope that clears or this analogy is helpful to understand the meaning of limiting reagents and excess reagent. Okay, so I'm going to show you a sample problem on how to solve for reactions, how to solve stoichiometric problems with limiting reagents. So we have here a reaction and we're given the initial amounts of our reactants. So we have manganese dioxide and hydrochloric acid. And we have manganese chloride plus chlorine plus water as the products. So again, stoichiometry, we need the balanced chemical equation. So you can check this on your own, but I already balanced it. So it's manganese dioxide plus 4 hydrochloric acid forming manganese chloride plus chlorine plus 2 water. Okay, now we need to determine which is the limiting reagent because the limiting reagent will be our basis to compute for the amount of product that is produced in the reaction. So we're given 0.86 moles of manganese dioxide and we are given 48.62 grams of HCl. So try solving this on your own. This one is equivalent to 1.33 moles of HCl. So we have 1.33 moles. Okay. So our stoichiometric ratio is 1:4. So which do you think is the limiting reactant? Okay, so one way to check is, okay, if I have 0.86 moles of MnO2 or manganese dioxide, how many moles of hydrochloric acid is it stoichiometric with? So let's put the stoichiometric factor here. So that's 1 mole MnO2 in the denominator and 4 moles of HCl in the numerator. So this will give me 3.44 moles of HCl. Okay, if I use 0.86 moles of manganese dioxide, I need 3.44 moles of hydrochloric acid for the amounts to be stoichiometric. But I only used 1.33 moles of hydrochloric acid. Therefore, our limiting reagent is hydrochloric acid. Okay, I hope you got that. So now we can answer this second question. How many grams of chlorine will be produced? Okay, so since we have determined hydrochloric acid to be the limiting reagent, we will use it as our basis. Okay, so 1.33 moles of HCl, and then we're going to use a stoichiometric factor, but this time this is the factor between HCl and Cl2. So in our balanced chemical equation, we have 4 moles of HCl. So in our numerator, I'm gonna write 1 mole of Cl2. Then, because I want to get the mass or grams of Cl2, I'm gonna use its molar mass. So it's 70.9 grams of Cl2 divided by 1 mole of Cl2. So using your calculator, this will give me 23.57 grams of Cl2. Okay, so that's it for our review on stoichiometry and chemical reactions.